So here I have another differential equation here. And again, I'm going to try the same kind of strategy. I'm going to say, well, I'm going to make an assumption. And I'm not going to write down y1 and y2 like I did before, because we've already seen how that kind of worked out. But I'm going to get two answers from this. So I'm just going to say, this is my y, this is my proposed solution, some constant. And I don't even need the subscript because I'm only trying one solution. Right? So C e to the lambda t. And if I do that, y prime is C lambda e to the lambda t, and y double prime is C lambda squared e to the lambda t. And every time we do this, what we're going to effectively do is we're going to give an e to the lambda t and a c in each term. Those are all going to go away, and we'll have to deal with whatever's left. Again, c and e lambda t are in every term. Whoops, I didn't factor that. I have to put lambda there. And again, this can't be 0, therefore this has to be 0. And I look at this and I say, well, if that's going to be 0, I'll factor it, except I can't. But of course, we have a solution to find answers when we can't factor it. And that's called the quadratic formula. Right? So lambda equals minus b plus or minus square root b squared minus 4ac, sounds like plus 40, all over 2 times a, that's just 2. So lambda gives me 5 plus or minus, it's like square root of 65, whatever that is, over 2, and that is 2 solutions. And those 2 solutions will solve this system. Now, those solutions aren't as pretty as the other ones that we have 5 and 2, those are nice numbers, but what this is saying is that y1 would be C1 e to the 5 plus square root of 65 over 2, and y2 would be C2 e to the 5 minus square root of 65 over 2, but those, and then there's a t in there. But then those are in fact 2 solutions, and if we put those 2 solutions in there, and we say the total answer is that one plus that one, and if we take the first derivative, second derivative, and plug them in here, it will work, and those will be the solutions to that. Now the other thing, of course, that can happen here, when we look at this, is you say, well, what if this had been a plus 8? If that's a plus 8, then that's not a big change for the whole thing, except that what happens right here, that becomes a minus. Once that becomes a minus, this becomes imaginary. All right? I got square root then of negative 15. So we pull the I out and say, well, it's 5 plus or minus I radical 15 all over 2. Okay, in that situation, now we don't have real solutions, we have an imaginary solution.